All right, mathletes, we are going to continue on with these sequences in series. So 12.2, we're looking at an arithmetic sequence. So an arithmetic sequence, it's a recursive sequence. And recursive means that, each term is dependent on the previous one, or however many terms they're using. But an arithmetic sequence is only going to use just the previous term. So it's defined as the first term is just a, and then a sub n equals a sub n plus n minus 1 plus d. So to get the next term, you're adding this constant of d to your previous term every single time. And that d is the common difference. Well, what's the common difference? It's the difference between consecutive terms. So we'll get into that in just a moment. And then the nth term of the arithmetic sequence is generated by this. So you're taking the a, which is your starting value, plus n minus 1 times the d. Okay, so that's the general stuff. So now let's get into some specifics so you can see how it works. So example 1, find the nth term of the arithmetic sequence whose initial term a and common difference are given. What is the 51st term? So we're going to use this nth term of the arithmetic sequence. So we're just going to fill in what we have. So the first term is 2, so that's our a. Plus n minus 1, because we don't know n when we're just filling this out. And then times our d, which in this case is the 3. So there's your nth term. Oops, and we can stick in the 2 for the a. So if we want, we can, actually we should, because it said to find the nth term of the sequence, didn't follow my own directions. So let's distribute the 3 and then combine like terms. So we end up with 3n minus 1. So that's your nth term. So that's the first part of the question. The second part of the question is, what's the 51st term? Well, now you know what n is. So you can just plug that right in there for n. So 3 times n, or 3 times 51 minus 1 gives us 152. That would be the second part. All right, let's try it again just to make sure we have it. So the nth term, take the initial term, the 1, and then plus n minus 1 times that common difference, which in this case is a negative 1/3. So the common difference can be any number. It can be positive, it can be negative, it can be a fraction, it can be anything it wants. So if we distributed and combine like terms, we end up with 4/3 minus 1/3 n. So there's your nth term. And then the 51st term, plug in 51 for the n. And it comes out as a negative 47/3. All right, so that's kind of a straightforward direction. Well, now let's kind of go a little not so straightforward. So example 2, find the indicated term of the sequence. So we want the 90th term of this sequence here. So we're starting with 1, then negative 2, then negative 5. So our common difference is just the difference between each of the numbers. So like, what are you adding or subtracting to 1 to make it negative 2? Well, that'd have to be negative 3. And it's the same all the way down. So to get the next term, we're just subtracting 3. So our difference, that common difference, is just negative 3. So we're going to use that nth term again. So a sub n is equal to, our first term is 1 plus n minus 1 times negative 3. Now, it didn't ask for the nth term, so we don't need to get it if you don't want to. You can, if you want, you can distribute, work it out to this. But since they didn't ask for it, I'm not going to find it just because I don't want to. And I'm going to get right to the heart of the matter, that term, the 90th term. So plug in 90 for the n. So 90 minus 1 is 89. Times it by a -3. And if you do the arithmetic, we end up with -266. Okay, so let's try part B just because it's a little interesting. Oh, now you've got radicals. So the common difference, or what you're adding every time to give you the next term, is 2 root 5. So that's the D. So I'm going to do the same thing as I did in the previous example. Just set up the nth term. So the first term is 2 root 5 plus n minus 1 times that difference of 2 root 5. So now I can plug in the 70 to get the 70th term. So 70 minus 1 would be 69. And then I just work out the arithmetic again. So I'm actually going to combine like terms to start because I have 2 root 5 here, and I have 69 more 2 root 5. So that gives me 70 2 root 5s, or 140 root 5. All right, I'll go ahead and stop the video here, and in the next one, we'll kind of go a little bit backwards.